Alrighty, so we've got section 13.4, which is parabolas. We've already spent a lot of time with the regular vertical parabolas of the form y equals a times x minus h squared plus k. This is vertical. Your vertex is hk. We know it opens up if a is positive and down if a is negative. But what about this idea of a horizontal parabola? Can one exist? Sure. And the equation is just kind of pretty much an inverse of this. It's x all by itself, y is stuck in the squared thing, but there's still an a. Please note that the k is still with the h, just like all the other conic sections. And the h could be subtracted over. You could have the x minus h along with the y minus k, but we haven't. We've thrown the x over to the other side. So it comes through as positive. So just like here, what's being subtracted, what's being added is your hk. Here, what's being added, what's being subtracted become our hk. And in addition, it opens, if a is positive, it's not that it opens in a positive upward, it opens in a positive rightward direction. And if it's a negative a value, it's going to open to the left and be kind of a negative working backwards parabola. I think that can be common sense as long as you recognize that the number line moves positive this direction, right? So if it's positive, it's going to open to the right, negative, it opens to the left. So let's take a look at this one right here. X equals 4 times y minus 1 squared plus 3. Is this horizontal or vertical? Well, because the x is by itself and the y is squared, because the y is squared, this is going to be one of those horizontal ones. Which means it doesn't open up or down, it opens either left or right. And because my a, which is 4, is positive, I know this is going to open to the right in a positive direction. What's my vertex? My vertex is hk. What am I adding? Looks like I'm adding 3. What am I subtracting? Looks like I'm subtracting 1, so my vertex is 3, 1. And if I were to graph this in Desmos, have I mentioned Desmos before? Desmos.com. It could very well be your best friend during the quarantine. This right here ends up being our parabola. You notice that it has a vertex of 3, 1, and it opens in that sideways direction. So that's kind of it. Though I do want to make a quick mention of something dealing with parabolas. Parabolic dish. What is the parabola? How many of you have Dish Network or have seen those dishes on the side of a house? This is what a parabola is. You have what's called a focal point that we did not talk about finding. And the interesting thing about a focal point along with this dish is the dish is shaped perfectly, and this is in the exact correct place so that signals coming in or out are going to all be reflected so that they leave parallel, which is very useful to us if we're wanting to either send a signal to the satellite that says, hey, can we watch this movie? For the satellite then to just beam back down and for the dish to collect all of those signals in so you can watch the new Frozen movie, and the receiver collects all of that information. Headlights. If you've looked at a headlight and changed the headlight, you've seen that really crazy shape. And the neat thing about it is, if you have a high beam and a low beam with that parabolic shape, you put the high beam and low beam in a slightly different place, and all those things are going to be shifted this way, still running parallel, but going that way, which means they aim at the ground and not in the other driver's eyes. Parabolas, huge application in things, especially if you have this three-dimensional mirror, which is what all of the dishes are. But I've said too much already. That's chapter 13. Email me with questions.